Yeah, the notes are the first page in your packet. We are looking at limits. We've already talked about these briefly with when we did the continuity test, so we'll just look at it a little more formally right now. There's a lot of information on this page. We're going to look at some of it. First, the way you say this, like if I am reading this, you would say the limit of f of x is implicit. Are we ready? You would say the limit of f of x as x approaches a equals L. Okay, so I just want to make sure you understand the correct way to say it. And when we're talking about a limit, remember it's not the value at that exact point. It is what it is approaching from the left and from the right. So if we come down here to this first example, this is my function, this is the table of values, and this is the graph of that function. If I'm looking for the limit as x approaches 3, you can either look at the table, what are your y values approaching? Look at the graph, what are your y values approaching as x gets close to 3? What do you guys see? 6, and it eventually reaches 6 also, right? So those are both 6. Okay. So if we look at our next function here, g of x, very similar. I could factor it first. X minus 3, x plus 3, all over x minus 3. What happens to my x minus 3s? Yeah, they're gone, so we have a hole at x equals 3. And guys, you can see it better in this graph over here that I'm putting in the box. You guys see how there's that lovely hole? Okay, but let's think about the limit. As I come from the left and from the right, even though there's a hole there, what are my y values approaching? Still 6, right? So if I asked you for g of 3, like the actual function value, that does not exist. But the limit of g of x as x approaches 3 does. It's 6. Okay? You with me? Okay. So let's try a couple. So look at number 1 down here. I want you to try to do A, B, C, and D for me. So just looking at that graph, what are those limits?
X equals 0.
Okay, stop. Yeah. Yes. Yeah, because if you don't have any asymptotes, then you're fine. But none of these that I'm giving you right here are continuous functions, so.
Because I'm thinking, like, if you have, like, a parabola, like, in your study pocket, and then the limit is somewhere, like, by, let's say, like, positive 20.
The parabola still keeps going, though, right?
Even though it's not even moving.
Yeah. Yep. It would still exist. One of them is D and E. Yes, one of them does not exist. All right, guys, what'd you get for A? 4. What did you get for B?
3.
Good. What'd you get for C?
Does not exist.
Good. And what about for D?
0.
All right, guys. Anybody questions? Did you say?
Like, is there like a way to like show like a
Negative infinity to 0. What do you mean?
we're just trying to learn.
Yeah, and that's what, if you look at the right side of your notes there, we're going to do the left-hand limit and the right-hand limit next. This is overall limit, because this, like this first one, this is as x approaches -5. From the right, from the left together, like what is the approach? So that's like your general limit, or your overall limit, okay? All right, guys, any other questions on that one? What? This is a calculus concept, very basic one, but yeah. You'll see on,
We was 9.
we get into derivatives this unit, so. All right. Yeah, we're into Calc A. All right, guys, so top of the next page there. We can look at limits from the left or from the right individually. So do you see that first one, how it's A and then above it is a tiny little negative? I know it's really, really small. Even on your paper, it's tiny. But you guys see that little negative? Okay. You're young, you have good eyes, right? That's the left-hand limit. Because of that tiny little negative right there. That means we are only looking at approaching from the left. We don't care at all what is happening from the right. We only care about approaching from the left. And so then the second one, you guys see that teeny tiny little plus sign on it? So what do you think that one's going to be? The right hand. No, not that is the right hand limit. Now, yes, this does require you to know your left and your right. It's challenging for some, I know. I think you guys can do it. It does. I've had people say that and then they like turn their hands over. I'm like, what are you doing? Oh, yeah. No. All right, guys, so let's look at this example here. We are looking at the function absolute value of x over x. And we are trying to find, we're looking at the limit as x approaches 0. Here is your graph, either of these, this guy or this guy, I don't care which one you look at. So as we approach 0 from the left, everybody see that this is the piece I'm looking at? Because that's coming from the left. So what does it equal? -1, right? So on the blank here, what we can say is the limit of our function as x approaches 0 from the left equals -1. Well, so when we're saying from the left, all we care about is going from the left, and as we get close to 0, what does it do? We don't care what's happening up above. Like, I could even zoom in on this and be like, I only want to look at that little part. That's fancy. Look at that. That is fancy. One of 2 smart pictures that I have. So we are, see where I wrote it in orange there? Limit of f of x as x approaches 0 from the left. That's what we're looking at. So then if I do the limit, that's magic pen, which means it will disappear. So that's probably not how you it like fades away, see?
So like when you make the original pencil.
Yes, just like that. All right, so then what about as we approach 0 from the right? No, that's 1, because as we come from the right, isn't it up here?
So wouldn't it simultaneously be 1 and -1?
Okay, so from the left is -1, from the right is +1. What do you think that means about the overall limit? Does not exist. Did your left and your right run into each other? No. So then that's actually way down here. You would say does not exist. So guys, this box here, that's just explaining to you that the left-hand limit and the right-hand limit have to equal each other for the overall limit to exist. So if your 2 sides don't run into each other, then the limit does not exist, the general limit there, okay? All right, so you guys try number 3 down here. And make sure you pay attention to those teeny tiny little negatives and positives.
The y-axis isn't the
Oh, you can see it on mine, right?
Yeah.
Does that help you? Okay. You guys done or need a minute? All right, guys, what'd you get for A? 3. What'd you get for B? Everybody. 1. What'd you get for C?
Danny.
Okay, you guys did it. They don't match. It does not exist. Okay.
Oh, does not match.
You need it to be an E. Yep. All right, letter D. What'd you get?
2.
Okay, E is 2. They match. It's 2. Easy? Yes? Okay, turn the page.
I don't think it's going to.
Sure.
If it did, I don't know if it was.
It snows. You can go to the grill outside.
Well, if the black dot is shifted over 1, then it's no longer a function, so you have a problem. You see what I mean?
Yeah, so what does that do? Like, how
If I had asked you, let's see, this is G, right? If I said find G of 1, 2, 3, 4, 5, you would tell me 1. But the limit of G of X as X approaches 5 is 2.
So that just,
All that dot is the function value when X is 5.
I think your regular
Okay.
class is not going to be
Also, for that, also the limit is 1.
Can we see me?
No, it equals 1 at that point, but what is it approaching? Approaching. Not what it equals at that exact value. Yeah. Limit is what are you approaching, not necessarily what is it when you're there. Okay. All right. Bella, what did you say? Got to watch the what?
Where was Mr. Matthews' size?
We can watch the clip. I don't think we have time for it today, but we will definitely watch it. My regular class hasn't done one yet, so
Yeah.
they didn't do the continuity stuff the way you guys did. They just had to look at the graph and say, like, is it continuous or not? They didn't have to go through the test. All right, guys, so infinite limits. This is if you have an asymptote. All right, guys, so let's look. So if I look at this, the limit as X approaches 3, here's my table, here's my graph. So if I come from the left, where is my graph going? Negative infinity. So if we're talking about the limit at a specific X value, and it's going to infinity or negative infinity, you tell me the direction, but then you also tell me does not exist. Because if I'm talking about as X approaches 3, 3 is a defined number, right? Then for the limit to exist, it would have to approach a defined value. Infinity is not one specific value. So you tell me the direction, hey, it's going towards negative infinity, but I know that really doesn't exist. Okay? So let's do the right-hand limit. So as I come from the right, where is it going? Yeah, so like positive infinity. But what else are you going to tell me?
It does not
It
exist.
does not exist. Right. So then the overall limit. Well, were they, I know they didn't exist, but were they even going the same direction, the left and the right?
Nope.
No. So all you have to tell me for that one is does not exist.
I just wanted to say it does not exist because
Does it go to a specific value? Okay, doesn't that go to a specific number? Isn't it approaching, like, so the difference here, this was approaching, so yes, we had a hole there, but it's approaching 2, right? 2 is a defined value, correct? Okay, here it's approaching infinity. Is infinity a defined value? So that's why it doesn't exist. because it's just going to keep going forever.
Could you just say does not exist instead of
You have to tell me the direction it's going and then does not exist.
I say it doesn't exist. Are you implying that? I guess it's just a mathematical concept that infinity just never stops or you find it.
Can't you always add 1 to whatever number you have? It can get bigger by 1 every time, right? So that's why. The only time you can have infinity as an answer, so remember when we did like end behavior, like limit of your function as x approaches infinity? And maybe you had a graph that like did this. If this is infinity, your answer can be infinity. But if what x is approaching is a number, then it can't equal infinity. Does that make sense? Okay, so if this is defined, this would have to be defined. So end behavior, don't change how you did end behavior before. That's still the same thing. But limits like at a specific place in the middle of your graph are different. Okay, let's do another one. So this time we're looking at 1 over x squared as x approaches 0. So from the left, where am I going? So you're going to tell me infinity does not exist. From the right-hand side, what are you going to tell me? Okay, infinity does not exist. So left and right, are they going the same way or opposite ways? So what do you think you're going to tell me for the overall limit? Infinity does not exist. Okay? Not hard, right? Okay. Sometimes you'll have to graph them on your calculator. The only one you'll have to do by hand is if I give you like piecewise graphs, but they'll be pretty simple graphs. Grace?
Looks like your graph was infinity and the other side of your graph was a kind of value. Does that happen?
That could happen, yeah.
Okay, so if that was the case, would it be infinity does not exist or would it be just?
Well, did they match? So just does not exist then. Yep. The only reason this one is infinity does not exist is because the left and the right are both doing that. If you had one where this side's going to infinity and this side is like, you know, stopping right there. Like if you asked me the limit as x approaches 0, that would just be does not exist because the left side's doing one thing and the right side's doing a completely different thing. Okay. Yeah. Nothing overlaps there because you've got that open circle. Okay. All right, let's keep going. Okay. So we're skipping number 5, but we're going to come down here to this really pretty squiggly graph here.
Looks like a what's it called?
Looks like your heart monitor type thing. Yeah. So what that graph is doing, that is called oscillating. Okay? When a graph oscillates, and I like how it's described as oscillating so wildly, out of control, there's not one specific limit because your graph is jumping back and forth so much there's no way you can say, oh, it approached this. So when you see oscillating graphs like that, your limit is not going to exist. Because it goes back and forth so quickly, it's not at a specific point. It goes up and down so fast that it doesn't approach one specific value.
Even if it's like the ends?
So like sine and cosine, those don't oscillate quickly, right? Like,
Yeah.
okay, so those you could find the
But
limit.
like the ends of that graph.
Okay, if I asked you the limit out here,
Yeah.
you could absolutely tell me that. If I asked you the limit in the middle of this oscillation, nope.
Zoomed in before.
Nope, even look at the table here, like going by thousandths. Like you have almost -1 and then almost +1. Like they're totally different.
Wow, it's oscillating pretty well.
It is oscillating pretty wildly, yes. So, 3 times when you will tell me that a function does not exist. So, what we just talked about, if it is oscillating wildly, so when the graph oscillates wildly, Oh yeah.
Yeah, that was we went in a vocab. I don't think you're possible.
We're a day late, you know. Layla. So, how do you know if this graph is wild or not? So if you zoom in a little bit, like if you go by like your table or even by like tenths, and you can see a very smooth pattern, like something like a sine or cosine curve. That's not wild. It's when you go in, like here we're only changing by 1,000 every time, and it's jumping back and forth like it's out of control. Okay? Pretty much everything you're gonna see, if if you see something like that on your graph, that's wild, and just stop.
At the bottom.
We'll get there. We gotta get through our 3 reasons. All right, guys. So, what do you think might be another reason that we would say does not exist? Okay, we covered both. Yeah. So when the left and right hand limits are not equal. And then I think Elizabeth said the third one when we have an asymptote. Yeah. A pretty wild oscillation. All right, guys, so try number 4. Yes, that is considered wildly oscillating, okay? Moderate oscillation. It does look like it's sort of moderately wild. They could go either way. They could be pushed over the edge into wildness. Yeah, that.
What would be the equation for a wild?
There's one on your homework. Let me It usually has like something weird with the sine or the cosine, but not just your regular sine or cosine. Do these through pi, and then I'll find one for you, okay? Okay. Are you glad you came?
I was not
A and D are the same.
Okay. Then you should be good at it.
Okay.
Are you guys through I yet or not? Almost? Okay. All right, guys, what'd you get for A? Everyone, what'd you get for A? 0. What'd you get for B? What'd you get for C? Alright, you're on a roll. What about D? 3. E. 0. F. Alright. 8. 1. H. 1. I. Okay, easy? Alright. Try number 5 for me. You're going to graph this on your calculator and then look at the limit. It says as x approaches 3 from the left. So there's lots of, they're usually the truth. There's a wild loop. Yes, a wild oscillation. Alright guys, you got this one?
Okay, I can grab it.
What did you get? What did you get, Layla? 1. Yes. I know, I had her go.
She wasn't doing that. She was doing
I was doing a wild oscillation. If you guys want to see one that oscillates wildly, go ahead and graph y equals the cosine of pi over x. Just make sure you're in radians. If you just want to see a weird one.
How is that what you got?
We good?
I didn't quite get that.
You didn't get what, Becky?
Never mind. I got the X outside.
Oh, nope. Alright, we okay? Alright, we have just a little bit left, guys. Number 5, 1. And this is just an example if you want to see one on your calculator that's wild. Just if you want to see one. You're not doing, I mean, the limit's not going to exist as x approaches. If you're doing sine and cosine with a pi, yes, you're definitely going to work again. Alright. Last page, guys. That is a piecewise function. We can do it. Alright. Okay, so to figure out the limit as x approaches 2, we need to see what the graph is doing at 2. So we have this piecewise function. The first one, it says 3x plus 1 when x is less than 2. So let's figure out what's happening at 2. What do I get at 2? If I'm looking at this, because no, you need the endpoint. Yes, it's going to be an open circle, but where is that endpoint is what I'm asking. 7. So 1, 2, 3, 4, 5, 6. I did. And so I know I'm going to have an open circle there, right? And then I want everything less than 2, so I know I'm graphing to the left of that. You can use your slope. You can use, okay, I know the y-intercept is 1. I don't care. Get your line on there right. Because it's just x is less than 2.
I made my graph like this wrong.
Alright guys, then the second piece. I know when x equals 2, my y value is 8. So that means I have a dot up here at 2, 8. Okay? That's it for that piece. My third piece, this is when x is greater than 2. So we still need the endpoint. If I plug a 2 in, what do I get? 7. And again, that's an open circle at 2, 7. And then it's a parabola, so I know I've got, if I plugged in a 3, I'm going to get 12. Like, I know the graph is doing something like that, right?
That's a tricky one.
All right, so I am asking you the limit as x approaches 2. So for the limit as x approaches 2, do I care about that blue dot at all?
Probably not, right?
No, I don't. So look, from the left, from the right, are they going to run into each other?
Yeah, 7.
7, that's it.
But isn't the blue dot like a part of the function?
Yes, but does it have anything to do with the limit?
Yes.
If I ask you f of 2, yes, you would tell me 8. But if I ask you the limit of your function as x approaches 2, you are going to tell me 7. Okay?
Okay.
Nope. All right, guys. Let's look at 7. Your sometimes, always, or never questions. Takes you back to geometry. So if the limit as x approaches 2 does not exist, then the limit as x approaches 2 from the right does not exist. Sometimes, yes. They might both not exist, or the one from the right could exist, but the overall limit wouldn't. That's okay. What about letter B? If the limit from the right does not exist, then the limit does not exist. Always. Always. Okay, good. We're good with that. Okay, so the limit as x approaches 2 does not exist. So I could have something like, okay, and okay, right? There's my graph. So the overall limit doesn't. Does the limit from the right exist? Yes. Okay. What if I had... Does the overall... Yeah, you said, okay. Yeah, that's okay. All right, guys, skip 8 for me, and let's just do 9. So this is all from your graph here. Got some asymptotes this time. And you can't see it very well because it's the y-axis, but there definitely is an asymptote right in there. So I'll give you a minute. Or I can put it on a calculator part that usually has like graph sections and figures. All right, guys, you ready to go through them? No? Okay.
Little storybook. Scrapbook with your child. Yeah, it's doing that.
All right, guys. Letter A. What did you get, everybody? Should be 1. There's 2. To me, that looks like that lines up pretty well with 1. Okay. I would not give me decimals on these from a graph. That should be 1. All right, letter B. We're going down. What are you going to tell me? Infinity does not exist. Good. What about C? Okay. What about D? All right. I know I does not come next in the alphabet, but let's just keep going down. What are you going to get for I? 0. Okay, then up to E. What do you get? Yep, that's just regular old does not exist. What about F? Okay. G. Alright. And H. Just plain old does not exist. Okay.
Wow, there's a lot of houses.
Yes, there's a lot of does not exist. Alright, that is the end of notes. Homework, I'll write it up here since some of you did not get a homework.
That's like
Infinity and beyond, right?
what?
Alright guys, so here's what is on your assignment sheet. Oh, I gave you guys some yesterday. That's why I ran out. So guys, if you have 2 assignment sheets, give them to someone who does not have one. If you were gone yesterday, you don't have one. Okay. Yeah, good. I'm not losing my mind.
Why didn't you give it to me? No, Mr.
All right, I will collect them if you have extras.
You don't the first part?
Yeah, cross out the first part on it.
Like 7:35, that one?